Density. Density is defined as the mass of an object divided by its volume. So density equals mass over volume, or D equals M over V. So that's an equation you need to memorize. Density is a fundamental property of substances. The density of an object does not change with its size. Does the mass change? Yeah. But the volume changes also. And they change in the same proportion, so the ratio of mass to volume is always the same, regardless of the size of the object. Now, if you have a brick made out of aluminum or a brick made out of lead, same volume, the masses are going to be different because aluminum is not as dense as lead. So we can actually use density to identify an object, or the material that an object is made out of. So to calculate the density, we're going to use the equation. You just take the mass divided by the volume. So here's a simple example. A sample of liquid has a volume of 22.5 milliliters and a mass of 27.2 grams. Calculate the density. You need the equation. Density equals mass divided by volume. Now, on a multiple choice test, what if you forgot the equation? You knew it was one thing divided by the other, but you couldn't remember if it was mass over volume or volume over mass. That could happen, huh? Look at the units on the answers. The units on the answers are going to tell you what you should do. If you see grams per milliliter, then you know it's mass divided by volume. That's just a little tip. Okay, what's the mass? 27.2. So I take 27.2 grams, divide by the volume, 22.5 milliliters. How many sig figs should my density have? 3. 27.2 divided by 22.5. So as I'm writing this down, I'm going to write down the first 3 and underline the third one. That's where my sig figs end. And then I'm going to write down 2 extras. The units, gram divided by milliliter. Nothing's canceling there. It's okay. Those are units of density, grams over milliliters. So then rounding, I get 1.21 grams per milliliter as the density of the liquid. Questions? I don't think that slide's worth much. Let's look at this question. A customer purchases a platinum ring that has a mass of 9.67 grams and displaces 0.452 cubic centimeters of water. Is the ring genuine? We're given the density of platinum, 21.4 grams per cubic centimeter. If the ring is platinum, it doesn't matter the style, the size, the shape of the ring. The density of the platinum ring will be the same as the density of any other object made out of platinum. So to figure out if this ring is really platinum, we can calculate the density and compare it to the known density. So to calculate density, density is mass over volume. What's the mass of the ring? 9.67 grams. What's the volume? 0.452. We got to get the units in there, cubic centimeters. Now, it might be a little confusing. Displaces this much water, what the heck is that? Displacement of a liquid is one way to measure the volume of an oddly shaped object. A ring, to calculate using geometry, the volume of it would be difficult. You'd have to make lots of measurements, and it wouldn't be all that precise. So you can measure the volume of something by displacing. So you put some liquid into a container, you make a note of where the level is, you put the object in, the water level rises, right? That's what happens if you fill the bathtub to the top and you get in, a bunch of water comes out, right? Bless you. Your mom gets mad, you flooded the bathroom. Because you displaced the water. The amount of water you displaced corresponds to how much of your body was submerged in the water. So it's one way of measuring volume. So say this was a test question and displaces water. You're like, what the heck is that? You know you need a volume. You're not so sure about this water thing, but hey, cubic centimeter is a unit of volume, right? So, well, better than nothing, I'll use that as my volume. There's nothing wrong with that. 9.67 divided by 0.452. And here's another one with 3 sig figs. 21.3, there's my 3 sig figs, write down 2 more. Units, gram per cubic centimeter. When I round that, I get 21.4 grams per cubic centimeter. Oops, I mean to do that. Is this the answer to the problem? No. What's the question? Is the ring genuine? Is it? Yes. The density of the ring is the same as the density of platinum. What if I got 21.5? Would I consider that really different? No, because there's uncertainty in the last digit. This mass and this volume had uncertainty in them. And when we round this number, using the rules for significant figures, the density that we get reflects how the measurements were made. So as long as it's, within plus or minus 1 or 2 in that last digit, it's fine. So that the solution, the answer is yes, it's genuine. Any questions? We can use the density of a substance as a conversion factor. You can do these types of problems using algebra. If you're good at that, you don't need me to tell you how to do it. If you need me to tell you how to do it, it's not a good method for you. Don't do it. People do all kinds of crazy things. The density makes a great conversion factor. We learn dimensional analysis. We just put this in as a conversion factor. We don't have to learn anything new. Okay? So, for a liquid substance with a density of 1.32 grams per cubic centimeter, what volume should be measured to deliver a mass of 68.4 grams? Well, I'm given a density, 1.32 grams per cubic centimeter, and I'm given 68.4 grams. 2 numbers. I have to decide which one to start with. Probably this one, right? This looks like it could be a conversion factor. This one's not going to convert to anything. It is plain old grams. What am I trying to find? What? There's the question word. What volume? It doesn't give me a particular unit. If it doesn't request a particular unit, you are free to choose the most convenient one. What would be the most convenient unit here? Milliliters or cubic centimeters. They're actually the same. So 1 cubic centimeter equals 1 milliliter. That's an often overlooked relationship. Cubic centimeters is what we generally use for solids, and milliliters are generally used for liquids. But this density was given in grams per cubic centimeter. So if I choose cubic centimeters, then I don't have to do any messing around. So I can do this in one step to cubic centimeters because I have the density. Density is the conversion factor between mass and volume of a given object. 68.4 grams. I have one fraction. I'm going to put cubic centimeters on top. Grams to cubic centimeters. I'm going to put grams on the bottom. The grams cancel out. Units first. Get all the units in first. Then put the numbers in. So I'm going to use my density as a conversion factor. 1.32 grams. So the gram and the 1.32 have to stay together per cubic centimeter. Bothers some people to not have a number there. That's fine. Put a 1. So I'm doing the math here. I take 68.4 times 1 divided by 1.32. How many sig figs? 3. 51.8. 18. That one's kind of fun. It goes 18, 18, 18, 18, 18, 18. Sorry. So then to round, I look at the next digit, and it's small, so 51.8 cubic centimeters. Questions? You do not need to memorize densities. The only one that might be useful to remember is the density of liquid water is 1. It's not a coincidence. The density of water is 1. The rest of these, if you need it on an exam, I give them to you either in a table at the beginning or the end, or I might just give it to you in the problem. Okay. When you're doing homework, though, you might have to go look at this table. Mastering chemistry, you should be able to find any of the densities you need on here. So let's continue practicing density as a conversion factor. A drop of acetone, nail polish remover, has a mass of 35 milligrams and a density of 0.788 grams per cubic centimeter. What is its volume in cubic centimeters? So get those numbers. 35 milligrams, 0.788 grams. Write that as a vertical fraction. This is a conversion factor. If you write it horizontally, you sometimes overlook that. It's a vertical fraction, grams divided by cubic centimeters. And the question, what volume cubic centimeters? Well, I might get cubic centimeters over here. Oh, that's not far enough. Cubic centimeters. Actually, it would have been far enough. It's okay. I was thinking of the next one. Does this say anything about milligrams? No. So maybe we don't want to start at the beginning. Maybe we'd like to start at the end. Cubic centimeters, this has cubic centimeters. So this is the relationship between grams and cubic centimeters. So if I have grams in here, if I got to grams, then I could use this to get over here. You see that? And then we have to figure out how to connect this point and that point. Can I convert milligrams to grams? Yep. Sure. So I can do that. Sometimes it ends up more complicated than you thought originally. Sometimes it ends up easier. But this path is the key to the whole thing. Once you've got that, the rest is much simpler. So I'm starting with 35 milligrams. My path has 2 arrows, so my equation has 2 fractions. I'm going milligrams to grams to cubic centimeters, milligrams to grams to cubic centimeters. I'm going to put milligrams down here and grams down there. All the units. Cross off the ones that are canceling. Make sure that you're not just hoping they cancel, that they actually do. One on the top, one on the bottom. Cross them off. Then look for numbers. So I've got this density. I should probably use that. 0.788 grams. 0.788 grams per 1 cubic centimeter. I don't have to think about, do I multiply or do I divide? I just put this number with its unit. I already put the unit where it needs to be. This guy in the middle here, milligrams and grams. That's just using metric prefixes. Milli stands for 10 to the minus 3. Milli is down here. I'm going to put what it means on the other side of the line. So So instead of writing milli up here, I'm going to write what it means, 10 to the minus 3. 1 times 10 to the minus 3 grams is the same as 1 milligram. Any questions? And then as you go, start on the left, 35 times the top, divide by the bottom, times the top, divide by the bottom. If there are ones, you can skip those, but do everything else and just do them in order. 35 times 1 EE negative 3 divided by 0.788. And how many sig figs is this one going to have? 2. Because 35 milligrams is only 2 sig figs. I've got 441. And the unit that's not crossed off is cubic centimeters. And so when I round that, I get 0.044 cubic centimeters. We're still at a point where some of these things you could do using another method. I've done this a lot. I've seen lots of students do things. that means a lot, right? If you learn this method, some of the rest of the stuff that we're coming to is going to be a lot easier. You had a question?
Yeah, why did you put 0.788 on the second gram and not the first gram on top?
That's a good question. Why didn't I put the 0.788 here? Because this is grams and milligrams. And so this is giving me a relationship between grams and cubic centimeters. So I can only put this number where I have those same 2 units. Okay? It's a good question. Anybody else? I did that one in the morning lab, so I'm going to do this one. If you want to see that other one, you can watch their video. A gold-colored pebble is found in a stream. Its mass is 23.2 milligrams, and its volume is 1.20 cubic millimeters. What is its density in grams per cubic centimeter? Is it gold? And then they give us the density of gold. So we have to calculate the density. So to do that, we need the equation. Density equals mass divided by volume. So what's its mass? 23.2 milligrams. And the volume? 1.20 cubic millimeters. If I do the math here, am I going to end up with grams per cubic centimeter? I'm going to end up with milligrams per cubic millimeter. It's not the same. So there's 2 things you could do. You could convert the mass to grams, and then separately convert the volume to cubic centimeters, and then put them into the equation. Or you could convert them right here where they are. Because there's some problems on the worksheet that require you to do some stuff like that, I'm going to do it that way. So I've got milligrams per cubic millimeter. I'm going to put this up here. Milligrams per cubic millimeter. And I want to end up with grams per cubic centimeter. There are times when you have to take per units and convert them. So what we want to do here is recognize that we're doing 2 conversions. So I'm just going to continue the fraction line. And what I'm doing is I need to convert milligrams to grams. Can I do that in one step? Yeah, I can. So I could do that in one step. Millimeters cubed to centimeters cubed. There are 2 prefixes, centimeters and millimeters. When you see 2 prefixes, do 2 steps. So I want to go to meters first, meters cubed, and then to centimeters cubed. there's 3 arrows. I'm going to have 3 conversion factors. I always like to do the top first and then the bottom. So I'm going to look at the top, milligrams to grams. Here's my milligrams. I'm going to write grams here. And I'm going to put milligrams down there so the units cancel out. Everybody okay with that? Now, if I stopped, I'd have grams per cubic millimeter. So now I'm going to do these other 2 arrows. These are both happening under the line, downstairs, cubic millimeters to cubic meters to cubic centimeters. Here's cubic millimeters, that unit. It's also downstairs in the denominator under the line. So I'm going to write these guys on the bottom because that's where they started and that's where they're going to end up. Because I'm converting the denominator. So in the denominator, cubic millimeters to cubic meters to cubic centimeters. In the denominator, cubic millimeters to, skip that, cubic meters to cubic centimeters. Okay? If I want to cancel cubic millimeters, because it's in the denominator, I need to put it on the top. This is ending up upside down because we're dealing with the denominator. So cubic millimeters then would cancel out. And now I need to get rid of this, so I'm going to multiply by that. If this is making your head spin, just stop listening. You can pass this class without getting this. But I want to expose you to this. I want you to know about this. Because a bunch of you will get it. But I don't want to overwhelm those who aren't getting it. All the units are in place. Any questions? Now the numbers. So grams and milligrams. Milli means 10 to the minus 3. Milli is in the denominator. I write what it means in the numerator. Milli means 10 to the minus 3. So 10 to the minus 3 is 1 milligram. Milli is just an abbreviation for 10 to the minus 3. It's a nickname. Millimeters and meters, they're both cubed. Think of them not cubed first. Well, milli, here we've got milli again. Milli on the top, this time what it means goes on the bottom. 10 to the minus 3 is 1 millimeter, but it's cubed. So I have to cube the 1, and I have to cube that. Oh my God, this is getting ugly. Yeah, it is. Cubic centimeters, cubic meters. We put in what centi means. Here's centis in the bottom, so we put what it means on the top. It means 10 to the minus 2. 1 centimeter is 10 to the minus 2 meters, but this is cubed. So I have to cube the units as well. I mean the numbers. Cube the numbers as well. So the rest of this is a mess for your calculator. I'm not going to cover that because calculators are different, but I'll do the problem and show you what the answer is. So this is what I'm doing on my TI-36X Pro. 23.2 divided by 1.2. And I'm going to multiply by the top times 1 EE negative 3, divide by the bottom, I'm ignoring the ones, times 1 cubed, ignore that, divide by, I'm opening parentheses, 1 EE negative 3, close parentheses, raised to the 3rd power, times, whoops, okay, that's multiplying my exponent, so I need to move my cursor over so it comes back down, times, open parentheses, 1 EE negative 2, close parentheses, raised to the 3rd power equals. That should have 3 significant figures. I'm getting 19.333, grams per cubic centimeter, which would round to 19.3 grams per cubic centimeter. Is it gold?
Yes.
Probably. Yes.